This is Group J of Dr. Rashidi's Design and Manufacturing class, presenting a second project on product design improvements. From common household products to essential tools for anyone, our project aims to increase the sustainability, ease of use, manufacturing, and quality of these products by adding improvements that could be easily manufactured or implemented.
The next product, a new product, is called the Modular Dorm Bed Attachment. So this product we sought to solve the problem of not having enough space in the dorm room, as well as not having a reliable nightstand next to a bed to put stuff. And so in designing this product, we designed for cost and manufacturing. First, cost is important because college students don't have a lot of money, and making the product modular highly reduces the cost as many parts can be used with other parts as well. And designing for manufacturing, we sought to reduce cost through that way by using reliable and cheap manufacturing processes. So the manufacturing processes that we suggest are first 3D printing. You can see that I've CAD'd and prototyped this product to the right, and 3D printing is suitable for any hobbyist or anyone who wants to replicate this design, as well as injection molding. So if you were to scale this product to a larger production, you would use injection molding to do that. And so you can see the video here how this whole product comes together. So first we are mounting the bracket on the bed frame, as well as the headphone stand on top of that, and then the headphones sit lightly on that headphone stand. And so a few additional attachments can be a watch stand, a phone docking station, or a jewelry holder. Essentially, this product is meant to be a one-size-fits-all for many applications and to hold many things near a bed. To improve a product used by so many Americans, especially during the summertime, we created the all-terrain cooler. So in creating this, we designed for accessibility. The problem that we were solving is that some coolers got stuck in hard terrain such as sand or maybe mud or some type of deep grass, and so we were designing for accessibility. And the way we did that was creating a ball and socket quick release joint system, which allows you to replace the wheels at the snap of a finger. So one or two possible combinations we have to the right are rubber wheels, which can work well in sand, as well as your classic plastic wheels, which can work on hard terrain best. And for our manufacturing processes, first we wanted to injection mold the ball part of the ball and socket. And this allows for a cheap manufacturing as well as a relatively medium strength, which is good enough for this product. And for the wheels, we decided that they should be outsourced to an overseas manufacturer, as there are many different types that we'd like to create and many different combinations that we'd like to use.
So here we have the portable can cooler idea, and as you can see, there are 5 major parts. There's the rectangular prism, which acts as a handle for your hand, the half dome, which the soda can will clip into, and then the 2 gears, with one of them being connected to the soda can dome and the other one being connected to a lever in which you twist. And the way this works is the soda can will lock into place in the half dome, and then you'll place it in the ice and then rotate the lever. And this allows the soda can to spin in the ice or ice water, which allows the soda can to cool down to your desired temperature and have it not be room temperature. Now when designing this, I designed for X, for design for assembly, and design for manufacture, and also design for reliability. And this is because of the very few parts it has. There are 5 major parts, and 2 of them are the same gear. And because of this, it's a lot easier to assemble because of it's not complex, and it's less reliable because there are less things to break. Now when choosing the materials for this part, I chose plastic for the dome and metal for the gears and lever. This is because the plastic is elastic enough that allows the soda can to clip into place, and the metal has enough yield strength to where it wouldn't break under the torque caused by the rotating lever.
A common complaint for customers who have the Apple AirPods is the cleanliness and sanitation of the AirPods. Specifically, many customers complain about their AirPods case, as many people have trouble cleaning the magnetized areas of the case that have picked up metallic shavings or dust. For example, a student may be walking by the invention studio and drop his AirPods. He picks them up and suddenly there are dark, gritty metallic particles stuck to the interior of the AirPod case. Because the case is permanently magnetized, removing the dust is particularly difficult without using another magnet to demagnetize the entire case. Our proposal is a mechanism that turns off the case magnets temporarily at the touch of a button. This would allow for easier cleaning, and in terms of design for X, it would fulfill the requirements for maintenance. Quality is achieved by extending the product's lifespan by not having to replace it as quickly as normal AirPods that have been excessively dirty. By having the magnets button activated, they ensure that the mechanism of the case is reliable and will have expected quality controls for cleaning. One design problem that may occur is choosing between a pure magnet or electromagnet for the case. To have a button-activated demagnetization mechanism, either the magnet field would have to be turned off by turning off the electrical current that is creating the field, or by inserting some superconductive material that can block the actual field itself. If choosing to use an electromagnet, the AirPods power supply may need to be increased to power the electromagnet as well as the charging functionalities of the actual case. The current design presented shows an electromagnet being used for the button activation. It features a redesign of the AirPod case to fit an internal electromagnet deactivated by the red button on the back of the case. The manufacturing process for this product would mainly be injection molding, as the AirPods are a plastic product and most of Apple's products manufacturing involves some sort of plastic molding. Another option could be vacuum forming, which could yield the same product at a cheaper price and with a faster turnover rate. However, vacuum forming is best suited for thin-walled parts, and the AirPods require a minimum sufficient thickness to be robust enough for daily use. When using an elevator, oftentimes a person will press the button to the wrong floor and are forced to stop multiple times to get to their destination. This problem is even worse in high-rise buildings or skyscrapers that may have over 50 floors. To save valuable time while traveling within these buildings, having a deselect button would be invaluable and ensures efficient product use. In terms of design for X, this improvement would be designing for reliability, as having the option to cancel incorrect floor inputs ensures no time is wasted traveling to the wrong floors. Quality is also achieved by designing the product so human error is accounted for and minimizing wait times for elevators. The manufacturing processes for this product could include CNC machining, laser machining, or water jet machining. All three are ideal for metal-based designs with strict design requirements, such as smooth surfaces and contours. Both laser and water jet machining are both cutting materials on a horizontal plane. However, water jet machining is much more powerful and can cut through thicker metals such as titanium, and is much more expensive. Laser machining is much more accurate and cheaper. For mass production of this product, the ideal choice would likely be laser machining. However, for prototyping with different materials and metals, water jet machining could also be a viable option. CNC machining, while offering a unique multi-axis manufacturing method, is limited by the tool size and diameter and takes longer to manufacture parts on average compared to water jet and laser machining.
Many Georgia Tech students, when coming to campus, find it a challenge to remove their dorm beds from the post because they are stuck on. They often need a mallet and have to hammer the dorm bed hard to physically remove the dorm bed from its post. This product helps this problem immensely. It is a giant lever that hooks in to the prongs on the Georgia Tech dorm beds to make it easier for you to raise the bed off of the post. And it's a simple cast molded design that has a strength durable enough to withstand the torque forces on it. There's a handle on the outside of it that makes it easier for the person to lift up the dorm bed, and the chamfered top helps prevent any damage to the dorm bed and to the lever. All the sides are chamfered to help prevent someone being cut by a sharp corner, and the design will be made out of steel. And it's made out of steel because it has the required yield strength and ultimate tensile strength to withstand all the torque forces being put on the lever. This lever is specifically designed for the Georgia Tech dorm beds, and it's to make the process of removing the dorm beds easier. The design for X for this is design for assembly, design for manufacture, design for reliability, and design for quality. This lever needs to not break when it's used, or else it'll cause severe harm and damage to the user. Because of this, it'll be cast molded using a steel with a high enough ultimate tensile strength and reliability. Since it'll be cast molded, here we have the cleaner cartridge for a record player. And the way this works is it's super simple, is you take off the old needle on the record player and you plug in this new cleaner cartridge into the record player arm using the 4 prongs, as you can see. And the top part will be made out of metal for durability and for strength, and the bottom part will be made out of felt. The top part will also be cast molded too. And since the felt is going to be in contact with the record as the arm goes over the record, cleaning it automatically, the felt has to be soft enough to where it cleans the record, but it doesn't scratch or dent the record too. This will allow the record to be cleaned seamlessly and effortlessly while still having a crisp and clear sound. Now the metal has to be durable enough for the human hands, and this is why plastic would not work and that we should go with metal. Now designing for X, this is designed for assembly, for manufacture, for reliability, and for quality. Because this is 2 simple parts, it's really easy to assemble and their little mistakes can be made. And it also has to be reliable too, to where it doesn't scratch up and dent the record. And the quality has to be high enough to where, again, it doesn't scratch or dent the record.
The next product is a laptop incline attachment. It's slim and compact, unlike other products, which are usually as big as laptops themselves. This is very similar to the incline system keyboards use. This makes it easy to carry within any laptop bag, or a suitcase, or even your pockets. The design for X factors that were considered during the design of this product were cost and manufacturing. The product is very small and doesn't require a lot of material, and that satisfies the cost design factor. As for manufacturing, we designed the product considering the limitations of 3D printers, as some consumers may want to create the attachment using their personal printer. Because of its simple design and relatively small size, it's easy to manufacture using a 3D printer. The attachment is made up of flexible material, and this allows for compatibility with different thicknesses of laptops. To attach the product, slightly pull the top piece and slide it onto the shoulder of your laptop. After both attachments have been put on the shoulders of your laptop will gain a 1-inch incline.
In conclusion, this project has taught us many valuable lessons and concepts about product design and what it means to improve a design. Designs do not have to be complicated. They can be as simple as a lever for moving bed frames. Although the problem of moving the bed frame may be physically intensive and naturally one would think heavier equipment is best to complete this task, a simple machine is all that is needed to make the task that much easier. For our all-terrain cooler, changing the axle for the wheels to a ball and socket joint made the modularity become very easy to achieve. Designs must have a goal intended for it to achieve, whether it is to lower cost, have higher quality materials, easier manufacturing and assembly, or ease of access for customers. Making a design improvement for the sake of improvement itself often leads to a product that has either already been created or an overcomplication of the design. Focusing on 2 or 3 aspects of design for X helped our group create designs that were engineered for specific goals for specific markets. For example, the AirPod demagnetization case is very specific. It only applies to AirPod users, but improves upon its accessibility and maintenance greatly. Also, balancing different design requirements is very important to consider when iterating a product. If designing for cost is a goal, but the product redesign requires robust and durable materials, then there is no balance of the design aspects. Another example would be if requiring water jet manufacturing, but also requiring a mass production of a product, then there is no balance of design requirements as well. Finally, it is vital to constantly improve and iterate ideas and existing designs for various products. True innovation in engineering and in product development comes from perpetual redesigns and developments to achieve a viable and exceptional product. Even when a solution is developed, considering an alternative that may be cheaper, use less parts, use an alternative manufacturing method, or add something to the product is crucial. Using the knowledge in this class, we hope to one day achieve such a design in the future.